Hello everyone, and welcome to part 2 of the Logistic Regression with Python lecture series. In part 1, we focused on exploring the data through visualizations. And through our exploration, we actually found that we had some missing data. What we want to do now is switch gears to cleaning our data. Cleaning our data will allow us to transform our data into an acceptable form for our machine learning algorithms. Let's go ahead and jump right back to the Jupyter Notebook where we left off last time. Okay, here I am at the Jupyter Notebook. If you remember from last time, we went ahead and used a little trick with train is null method and SNS heatmap in order to quickly create a mapping visualization to where we were missing data. We want to fill in missing data for the age column instead of just dropping all the missing age data rows. One way to do this is by filling in the mean age of all the passengers. This is known as imputation. And that means you could just take the average age and fill in the missing values with the average age. However, we can even be a step smarter about this and check the average age by passenger class. Let me go ahead and scroll down and show you what I mean by this. I'm going to go ahead and create a box plot using Seaborn with x equal to the p class column and y equal to the age column. And my data is going to be equal to train. And let's go ahead and run this and check out our box plot. What I'm going to go ahead and also do is set plt.figure fig size is equal to, let's go ahead and make this, let's say 10 by 7, just so it's quite a bit larger. All right, now we can kind of zoom in on the center points of this actual box plot. We can see here that when we separate by class, the wealthier passengers in the first class and second class tend to actually be a bit older than passengers in the third class. Now, you may think that this kind of makes sense because maybe wealth in order to reach the first or second class tiers takes age or time to accumulate. So if you have enough time to accumulate enough wealth, you'll be older and more likely to be in the first class. What we can do is use these average age values in order to impute the age based off of the passenger class. Now, if you wanted to, you could create an entire model to try to predict age based off of all the features, but we'll go ahead and use this sort of simple imputation, which is a little better than just imputing the average age. And by imputation, I just mean filling in. Let's go ahead and create a function in order to apply that function. I'll say impute underscore age, and it takes an argument cols. And then I'm going to go ahead and do is essentially say age. We'll go ahead and just say capital Age is equal to cols 0. So the first item there. And then we'll say p class is equal to cols the second item at index 1. And I'm going to say if pd is null of age, and then I'm going to have some if statements here. If p class is equal to 1, so if they're in the first class, I'm going to go ahead and return the average age for passengers in the first class. And that occurred at 37. And if you wanted to get this exact value, what you could do is just go ahead and actually get the average by class using pandas and just like say something like dot mean, or if you wanted to, you could create a box plot using plotly and just do it that way. So I'm going to say return 37, and then elif p class is equal to 2, meaning they're in the second class. I'm going to go ahead and return 29. And then finally else, meaning they're not in first class or not in second class, but they still have is null for age. I'm going to go ahead and return 24, which is the average value here for the third class. And then else on my outer if right here. So if the age is null, I'm going to go ahead and return a class, an age based off the class. Otherwise, I'm just going to return their age since I know it already. Okay, that's the function, and we're going to go ahead and apply that function. So I'm going to say train age is equal to train, and now I'm going to pass in age and the p class column, so a list of these columns, dot apply, and I pass in the name of the function I want to apply, and then set axis is equal to 1, because I want to apply this across the columns. And there we go. It ran correctly. Let me go ahead and break down real quick what's actually happening here. I've created a function here that takes in an argument calls. And notice here that I actually grab, based off my index values, the age and p class. And I'm able to do that because I'm using .apply on these two columns. And then I'm going to say if PD is null of that age, so at that particular point, then we check by passenger class. If it's first class, we return the average age for first class passenger. If it's second class passenger, we return 29. Otherwise, they're in the third class and their average age is 24. If it's not a null, then we actually know the age and we just return age. And then I went ahead and applied that function to these two columns here, and then I said axis equal to 1 to apply it to the columns. Now let's go ahead and check that heat map again. So say Seaborn, or SNS heat map, train is null, and set ytick labels equal to false, otherwise you'll see a ton of ytick labels, and then go ahead and set cbar equal to false. And if we run that, we get this color mapping scheme, but what I like to do is set my color map to Viridis, because it's a little easier for me to see. Okay, and it looks like now we are no longer having any missing information for the age column. We successfully put in values that were reasonable guesses for people's age based off of their class. Now the issue we have is the cabin column. And just honestly, there's too many missing points in order to actually do something useful with this column here. What you could do is try to create a new feature, something that says, did we know the cabin, 0 or 1? But there's just so much missing information here that it's just easier to go ahead and drop that cabin column. In order to do this, I'm going to say train.drop cabin, state that the axis is equal to 1, and then go ahead and say in place is equal to true. And if I check out train head, I'll notice that I'm no longer, if we go ahead and scroll to the right, have that cabin column. And if I go ahead and run this again, notice here, now we only have that missing value at embarked. Since this is just essentially one row of missing information, or one or two, very few rows, I'm going to go ahead and just drop any more missing values. So I'll say train.drop NA and set in place is equal to true. And now I should have no missing values. If I go ahead and run this one more time, boom. Now we have everything, one solid color, nothing is missing, we are good to go. Okay, we've taken care of the first step of cleaning data, which is dealing with missing values. We went ahead and filled in some missing values, and we went ahead and dropped some other missing values. Now what we need to do is deal with categorical features. We'll need to convert categorical features into what is known as a dummy variable using pandas. Otherwise, our machine learning algorithm won't be able to directly take in those features as inputs. And what I mean by that is something like this. If you see the sex column, here we have a categorical feature of male or female. A machine learning algorithm isn't going to be able to take in just a string of male or female. We'll have to create a new column indicating a 0 or 1 value for if someone is male or not, in order to encode that information in a way that a machine learning algorithm can understand it. And this is known as creating a dummy variable. And we'll do a similar thing for something like the embarked column. The embarked column here is just a letter representing a city. And again, a machine learning algorithm can't just take in that letter and immediately know what to do with it. It'll need something in a dummy variable format, which is going to indicate a 0 or 1 value with a column as the actual value for the city. Let me go ahead and explain this further by showing examples of how we can actually do this with pandas. I'm going to go ahead and say PD, and we're going to use the get underscore dummies method. And you can go ahead and click Shift Tab if you want to explore this method a little more, but what it basically does is convert categorical variables into dummy, or otherwise known as indicator variables. Then we pass in the column that we want to convert. So for instance, the sex column, male, female. If we just do this, notice what we get out. Now we have a data frame with a column for every single category and a 0 or 1 value, which is essentially just a Boolean. 0 if they were not female, 1 if they were female, and likewise for a male. Now there's one slight issue with this, in that one column here is a perfect predictor of the other column, meaning if our machine learning algorithm gets fed both columns, the machine learning algorithm will immediately know that, hey, if it's 0 at female, I can predict perfectly that it's going to be 1 at male. And this is going to be an issue known as multi-collinearity, and it basically will mess up the algorithm because a bunch of columns will be perfect predictors of another column. In order to avoid this, what you do is, as another argument here, you go ahead and say drop first equals true. And then it will go ahead and drop the first column, and now this is exactly what you want to feed in to your machine learning algorithm as a column. We'll go ahead and set this equal to sex. So sex is this data frame of just whether or not this person was male. And we're going to do a similar thing for the embark column. I'm going to create a data frame called embark, set it equal to pd get dummies, train, say embarked. We'll go ahead and say drop first is equal to true and run this. And then I'm going to go ahead and check out the embark data frame just ahead of it. And look here, I went ahead and dropped the C column, and now I have indicators of Q and S. But notice all the columns are not perfect predictors of each other because we went ahead and dropped that C column. Now what we can do is go ahead and say train is equal to pd.concat, and we're just going to use concatenation to add these new columns to our data frame. So pass in a list of the data frames we want. We want train, and then the new sex and embark data frames. And we'll set access is equal to 1 because we want to add them in as new columns. And if we check out the head of train, we get something that looks like this. Our normal columns, let me go and just make 2 rows here by passing in 2. Our normal columns, and then if we go over to the right, notice we have these new columns, male, Q, and S. And these are going to be our replacement columns for our machine learning algorithm. These are indicator or dummy variables. What that means is we don't really need a lot of these other columns anymore. We don't need this embarked column because we've already encoded it to Q and S. We don't need the sex column anymore because we already encoded it to this male column. Other columns we're not going to be able to use are things such as the ticket column or the name column. There's not too much information there that we can possibly use. If you want, you can try feature engineering new features, such as grabbing the first letter of the ticket, maybe, or the title of someone's name, but we'll go ahead and drop the columns that we're not going to use. So we'll say train.drop, and I'm going to pass in the columns I'm not going to use. I'm not going to use sex because we already encoded it to that male column. Likewise, for embarked, I'm not going to use that column because we already encoded it to that Q and S column. I'm not going to use someone's name because there's no way to easily pass that into a machine learning algorithm. Maybe we can feature engineer some stuff off of that, but it's quite complicated since we're dealing with text data. So we'll go ahead and wait till we get to something like natural language processing to get some ideas of how to work that sort of data. And then finally, I'm going to drop ticket because there's not an easy way to grab information for a machine learning algorithm with that. And finally, I'll need to say access is equal to 1 because these are all columns. And I'll state in place is equal to true. There we go. And now let's check out the head of our data frame. And this looks perfect for a machine learning algorithm. All the data is numerical, everything's concatenated together, and we have our columns working perfectly. The last thing we want to look at is this first numerical column, which is passenger ID. Notice this passenger ID is essentially just an index that starts at 1. If we go ahead and check the tail of this, it's the exact same thing, just an index that starts at 1. And that means that even though it's numerical, it's not really useful to us, it's essentially just an index, so we're not going to be able to predict whether a passenger survived just based off their position in an index. We'll go ahead and say drop, pass in passenger ID, and say access is equal to 1, and then we'll say in place is equal to true. Now let's check the head of this data frame one more time. All right, now let's take a quick look at the columns one last time to verify everything's okay. We have the survived column, which is 0 or 1. That's good because that's our label column. We have p-class column as the numerical indication of what class they were in. We have the age column of how old the passenger was. We have the sib-sp, how many siblings or spouses they had on board. We have the pair-ch, how many parents or children they had on board. The fare they paid, whether or not they were male, whether or not they embarked at Q, and whether or not they embarked at S. Something interesting to note about the p-class column is that it's actually a categorical column, meaning it can only have 3 distinct categories, 1, 2, or 3. And that means we could have also done pd.getDummies on that column. I'm going to go ahead and leave that to you as an exercise to do after you've already run the model with it as a normal column just by itself. And the reason for that is because I want you to explore the differences between leaving it as a column by itself of 1, 2, 3 versus using the pd.getDummies of the separation of those categories. And then you're going to be able to explore on your own how a machine learning algorithm will react to the column being treated as a category versus a continuous variable. All right, that's it for this part 2. What we did in part 2 is we went ahead and just cleaned the data, got rid of the missing data, filled in some other missing data, and we also learned how to use getDummies to create and deal with categorical columns. Coming up next is the final steps where we're actually going to create and train and build our machine learning classification model using logistic regression. All right, thanks everyone, and I'll see you at the final part 3 of this lecture series.